Okay, hello. This is week one of a series that I'm going to be starting, where I'm basically focusing on a particular topic each week, and then going to share the things that I am able to gather, test out, learn about those different tools, libraries, research papers that might come out. In this case, this week, for a while, I've been wanting to dig into the Magenta real-time music generation models. DeepMind, a couple of years ago, or I guess it was early 2025, they actually iffy. It was really interesting to actually see a music gen model that could actually do that segmentation and generate frames at a rate that was lower than or generate more music than the actual latency of inputs that you could give it prompts or MIDI signals to actually try and control and influence the music stream. So they've been able to reach a point now where this second generation, the input latency is around 200 milliseconds, sometimes less. It's very hardware dependent. But I've been testing this out a little bit on my local MacBook M4. It's a Max, so it's a little bit more beefed up than a general MacBook Pro would be, but I've had some decent results. But I'm going to pull up a few different things here, and I'll show you what I've been able to put together so far. Then let's do a little bit of an intro real quick on the actual library. So I'll pull that up here. Go ahead and share my screen. Here you go. And pull that in. So Magenta Real-Time 2. This is made by the Google DeepMind team. There's a subset that have been working on this for a couple of years now, but they have released a GitHub repo. So that's definitely something. If you did see my announcement earlier this week about this and were able to go look at it, great. If you were able to test it out on your own device, even better. But if not, there's a ton of interesting stuff to play with here. They've got pre-bundled versions of the software. So you can actually download these if you're into working with a DAW or an audio workstation, and you do any sort of music production, or you just play around and improv in your free time. There are some really interesting tools they've built out here. This Collider one, I've actually taken and tried to extend this a little bit further to do some things I've been interested in for a while around taking context of what you're doing and using that to actually generate new prompt context for the model and influence the music in real time. But a lot of really interesting examples here. I'll just kind of demo a couple of these real quick. So like MIDI steering. Things like, well, text to synth. There's one way to think about this is that we've had synthesizers for a long time of many different kinds, whether that was FM or modular or analog, or you doing waveform synthesis. But you can almost think about generative synthesis as another form where we're basically taking the descriptive text embeddings that are then mapped to the to different genres and types of music, and then training a transformer to generate new sound based off of those text embeddings that you give it. This stuff is super cool, so I could go through this all day. But worth going and digging into this. I'm going to be releasing or just updating a page on the GitHub repo every week where whenever I go over one of these different tools or dig into a new library, I'll take a bunch of notes. I'll gather resources. Can't hear any music if you're playing it. Hey there, Sage. What's up? Let's see if I can get that figured out real quick. If that was actually shared audio, that might be a problem given this is a audio stream. And the demo that I had put together actually has sound. I'll try to sort this out here. Interesting. So when you actually go to share something, oh, I see. Okay, it's just using a normal Chrome tab. We'll try this. So full screen, does that work a lot better? I'll go for that. I'll just do this one. Okay, and then to test that out again, can you hear sound now? No, nothing. Okay, that was like some aggressive dubstep. Let's see. I could try to beatbox it, but that would kind of defeat the whole purpose of building this stuff out with Magenta. All right, let me try one more thing here. How about now? I'm hoping you can actually hear the drop this time. Sound or no sound? Yes. Okay, awesome. So we actually have audio. Well, what I was talking about earlier was just this text to synth thing. I haven't gotten as far as actually being able to use a MIDI keyboard with this stuff yet, or with any of these tools, because I've been more playing around with the collider and actually building out a demo. But I'll go and just show that a little bit here. Let's see. So if we jump back over to that, I'll just keep everything in this window here so you can hear what we're doing. So the general idea of what I was trying to get at with Magenta is like, okay, this model allows you to work with real-time music. It would be really cool if you could feed it a little bit of context on what you're doing at any point while you're working on your laptop, and then use that to flavor the music that you're listening to, or the music that it is generating in real time. It's a little bit different in the way that it works from something like Suno or Ace, the open source library that you can use for generating like a large clip of music in the order of like 30 seconds, a minute, several minutes at a time. It basically only does about 25 hertz or 25 frames of 40 milliseconds at a time. And it remembers a little bit of the context from before. So it creates a relatively contiguous stream, but you're not going to get this perfectly pop structured stream of audio over a 3-minute song from this model. It just doesn't quite work that way. But I have a couple things here. So there's 2 different models that are actually available. Small, I would say, is probably sometimes I've actually had latency if I have too many things going on in this laptop. And again, this is an M4 Max. I've got 64 gigs of RAM. So there's a lot of bandwidth here from a CPU and GPU perspective. but it still will sometimes run into latency issues if there's too many other things. And on this laptop, I'm using the base model. So load that in, takes a few seconds. And then we have, what is this? Supersaw. I'm going to change that to melodic house. And then see if we actually get audio coming through here. So you can see down here in the top, in the bottom right, where it says engine, there's buffer. Okay, so it's coming through a little bit broken. I'll pause that for a second. So the buffer here, it's basically the model will try to generate a few seconds at a time ahead of the speed of your input or your prompts, or just the general play scroll. So if it's not able to generate more than a second every second, then you're going to get ahead of the buffer and you'll get clipping. Maybe if I try to jump down to the small model, we'll have a little bit more luck here. Might be because we're doing a live stream, so it's taking more bandwidth. So try that one more time. I don't know where the banjo is coming in from Melodic House. Anyway, I'm going to turn the volume down on that and let it keep going and figure itself out. Sometimes the stream will just evolve over time, but again, it's not super consistent. So there's a second tab here. I basically pulled over a little bit of the functionality from a previous demo that I had done in one of SageCode's actual lunch and learn sessions, where basically I was capturing context from the computer screen. So whenever I'm looking at a particular window, I would grab an image of that, feed it to a local or a remote setup LLM, have it describe what it actually sees in that image, and then feed that back, just to be able to capture the activity going on at any time. And I wanted to take that context and then turn that into some sort of prompt that could then be appended to whatever genre description is going on here for the music, and kind of flavor it based on what I'm doing at any point in time. Right now, I've got this actually set up with LM Studio using Link specifically, which is something they released recently. LM Link basically allows you to set up a separate remote device and connect to it from any other computer. You can even use your phone. I saw they updated recently. But I'll start that capturing. I can control the cadence here, so it'll go down to like 5 seconds. And then hopefully we actually start getting some image context coming through. I may have actually broken something. So let's... All right, I'll try to get this going again. So LM Studio, and make sure that I've got an actual model loaded. I'm using Gemma 4 QAT here, and that should start grabbing context. While that is attempting to load up, I'm going to jump over and actually look at some of the other notes that I had put together for this. So in general, a couple other things to note about Magenta. As I mentioned, there's a small model and a base model. The small one clearly seems to take up quite a bit less bandwidth. We're looking at around like 230 million parameters, whereas the base one, it sounds a lot better, but 2.4 billion, you definitely need a much beefier computer for that. Things that it was actually trained on, they used 71,000 hours of stock instrumental music, so you won't be able to generate voice with this model series. That was something that I was a little bit disappointed about. I was I was interested to try and feed in different text or lyrics as it went, and try to get that to actually feed into the model and emerge in the music somehow. But I think it would take some fine tuning. At least I don't know. It seems like they really didn't emphasize that, or stayed away from it, probably for liability. It is an Apache license, so it can be used for a lot of different things, but I don't know that I would, build an entire product out on it. But otherwise, they have the full GitHub repo. If you actually go here and look through what's available, there were a few different examples. The demo, prototype that I had just tried to build out over the past day was actually based on this one called Collider. So in Magenta examples, you've got this particular one, which shows this interface where you can add new nodes. And each one is going to have a different set of prompt context. You can change that to be, in this case, a saturated gamelan, which is a percussion device. I could add in I think there was a banjo playing in there a second ago, but I could also do like choir and have that play in the background. Let's see, and I'll try loading the base model again and see if we can get anything from that. Yeah, the latency is still seems to be the issue, so we got to go with small. It's really interesting that it's a Chinese guzheng. I think that is what it's really emphasizing here. I try to move it closer to that. But for some reason, it's coming through sounding like a banjo. That's super interesting. Let's try, just refresh and start again from... I think there's probably some quirks in the text embeddings or description around the different types of Okay, so I've relaunched, and I'll try this again. So I'm going to do the small. Again, only 230 million parameters, so it's a little bit quirky compared to the base model, and the base model is not anything like Suno quality to begin with. All right, so that's synthwave on the small model. There's a ton of that kind of audio data available, Creative Commons. So that I would expect to be a fairly easy one for it to replicate. If I added something in here like chiptunes, Medieval Rain, I have what would that even do? Chiptune, for instance, could have an interesting effect. If we actually move that closer to the node, it should emphasize that more. And as you can see down here in the engine, the buffer right now is around 3 to 4, maybe 5 seconds. That basically just means that it's able to generate that many seconds ahead of where the play reel is right now. So that continuous stream with the small model, at least right now, we're able to stay several seconds ahead of the live feed. And I think we go back to the base again and try to load that in, and okay, I'm sure reloading this. If we try to go back to the base again, dark cinematic soundtrack, that could be interesting. I'm doubtful that it's actually going to sound good though. Yeah, okay. As you can see, the buffer runs out. Okay, so if I jump back over to context capture, it looks like I'm still having an issue on that actually not working. But anyway, this is basically as far as I was able to get today. I am thinking that this next week I might continue to focus on Magenta, because there's a lot of different tools to play with within their base library. Like if I go back over here to the example apps, they have a bunch of different ones. Collider was this one we were just looking at, where at least not within Gradio, like I built it out into a demo, but just on its own, it gives you that ability to set up multiple different prompts and use those as input for the music stream. But there's others like Jam, which allow you to do a sort of real-time note input. I think I might actually have one of those that I could actually just launch. I'll see if I can find that real quick. Because I downloaded a few of the standalone apps as well. One sec here. MRT bundle, there we go. Okay, so Jam, I'll see if I can launch this one real quick. All right, so this was the one they were actually doing in that demo, and we'll see if it actually manages to keep up with latency here. All genres equal banjo. Oh God. Yeah, the quality's still here. I'll try to do some note inputs. Can I use my keyboard? Oh my God. Okay, let's try keyboard. Okay, so it is, the percussion's a little bit lacking, but it is changing notes based on this MIDI signal that I'm giving it for different keys. So a lot of interesting things you could do with this. I think the apps are just kind of a few different experiments that the research team put together to try to explore the possibilities of what you can even do with a real-time music stream. I feel like it's just, there's a lot of potential to augment things that you're doing. For me, the obvious thing was, okay, I want to do some sort of soundtrack, like background soundtrack based on what I'm focused on. I don't know if the quality is quite there yet. I remember there was a video that Lori Wired, who's a YouTuber that has done a lot of really technical deep dives on topics like real-time music gen, but also like often we'll dig into security and like the Linux kernel, or like why fading audio is extremely CPU heavy. So she gets pretty nerdy into certain topics, but one of the videos that she did was focused specifically on a previous version of, I think, the 2025 Magenta model. And she was having similar difficulties in that even at that point, it was still really rough with the actual sound output that you would get. If I can do like cosmic banjo, like what will it do with that, for instance? As you could, like, the quality is still difficult. Like, this is streaming at 48K, which is a normal bit rate for most music that you'd be listening to on your laptop or a phone or mobile device. But the actual, like, you get a lot of grain and texture that is not necessarily it's not necessarily intentional. It's sort of artifacting of the transformers process in taking those text to music embeddings or text to audio embeddings and actually regenerating something that fits your description. So it seems like there is still some improvement to be made in the amount of quality that you can get within this tiny time window of generating a few seconds of audio at a time in real time, like as you're listening to it. Maybe on more capable hardware, this wouldn't be as much of a difficulty, and you could build a larger model that was able to run at that same speed. But it seems like even with the base one, quality is like reasonable, but like if you compared that to someone actually playing a banjo and putting up that recording on Spotify, there's an artist I know of that does this specifically, and just the actual instrument quality, not even playing specifically, not their ability to express notes, just the sound quality of the output is still quite a bit lacking. Try the other one that I was doing from earlier in my prototype. Melodic house. That I would think is interesting. If you do more common, so again, back to this idea that we're dealing with text embeddings. So these are word to genre. Turn that down a little bit. Word to genre or token to genre, like a music genre, to the music sound mappings. So if you're putting in something super obscure that there is probably not much representation of in the embedding data, then you're gonna have probably poor quality in the generation. So something like melodic house, I mean, there's a million songs that are probably in that data set that were roughly in the house adjacent genre. So that's something that it's having no problem generating a relatively high quality signal of. Yeah, see, like that's actually playable. What if I try? Let's see. Well, actually, I'll pull up the other app that they had. So Collider. This is just their. These are both also implemented in C++. So when you're comparing this one to this demo that I had put together, this is running from the Python API. Or Python library, which it's still using MLX, Metal, the Metal API for Apple's hardware. So it's taking advantage of the particular CPU and GPU stack that is available in this laptop, but it's still not running as at low of a level as these dedicated apps are. So the sound quality that I'm able to get and the amount of buffer space when running from this, if I try to do, again, melodic house, because there's a lot of data available for that, but if we try to play it, yeah, it just struggles to keep up. That does not mean, though, these C++ implementations are going to have the same issue, because obviously they're a little bit more low-level access to the hardware, so they're more performant. Still looks like we're maxing out our buffer, though. I'm going to reset that and also kill my local app so that it's not taking any separate bandwidth from the GPU. Got jazz guitar, and we've got trance arpeggiated synth. That could be interesting. What if we do something like a jumble of text? Soft brush percussion from like a jazz ensemble. That would fit, I would think, a little bit more. Again, the core interaction here is just, all right, how much do you want to weight each of these different prompts as they get packaged and then given to the model to try to generate an output? We'll try the small model because that one seems to be having a lot better luck on this piece in this computer. I'm just going to get... Let's reload that. Yeah, so there's a lot of interesting things you could do with this. Just these two apps alone, I think, as I mentioned earlier, there are a few others. The Jam one, that's basically an actual instrument, as I was just showing you, where you can control direct notes, and you can hook this up to a MIDI instrument and play it in all kinds of different ways. I have one of these Rolly light pad blocks, and so this is pressure sensitive. I haven't looked into whether this model can actually take in MIDI data that would communicate on more dimensions than just whether a note is being pressed and the 127 quantized steps of intensity, because some instruments like that will have things like slide and glissando and all kinds of different parameters that you can use to make the notes more expressive. But they also have things like Max. So there's probably a plugin. I haven't loaded this one up yet, but where you can set up Max for Lives and do plugins within Ableton, or you can set up your own sort of audio visualizations. Yeah, so a lot of different things to be able to mess with here. I think what I will probably do this next week is continue to jam on the Magenta RealTime library, see if I can get latency for my own local device here ironed out a little bit better, because it seems like the base model is just not functioning all that well on this hardware. But yeah, it's super interesting. I think there's a lot of different there's a lot of different tools, and there's a lot of different ways to interact with the models that I think is worth exploring a little bit more, particularly MIDI input. Yeah, so I think that's probably what I will keep this all focused on for next week. Anyway, I'm going to be posting the library, or the updated, let's see, grab my tab here so you can see that. So I have a repo that I posted in GitHub that is going to be just following along with this series as I go through each of these different topics. First, I've got Magenta RealTime here, but there will be more. I think this is probably going to be for the next week. And then after that, I'll do something, or I'll get some suggestions from other people who might have dropped in, or find a tool or extension from this that can help layer on more interesting functionality on top of a real-time generative model, because Magenta is interesting in itself as an engine for real-time audio, but really the potential is plugging it into all kinds of different other use cases or other tools, giving it different kinds of context to be translated into audio. So there's a lot of experimentation room there. Yeah, anyway. If there's no other questions or anything, Sage, thanks for dropping in and supporting on this first one. I think lots of different things to improve and smooth out here as I go forward, but yeah, got to start somewhere. Anyway, I will post an event for the next one, and I'll see you next week.